Okay. Section 2.3, we are going to derive and apply the quadratic formula. So our objective is going to be able to find solutions. I can find solutions of any quadratic equation. So far, we can find the solutions to any quadratic equation by completing the square. But there's a shorter way than completing the square. So we're going to learn that today. So far, here's the methods that we have. You can solve a quadratic by graphing. Graphing isn't always accurate. So it's not always accurate. And it can't find imaginary ones. It's not going to find the imaginary solutions. So it's not the most useful. It is nice to get a visual and to see, but just graphing in general will just approximate. It always gets the approximate ones. We can use square roots, but that only works if we have something with an x in here squared equals a constant. So using square roots doesn't always work, only certain cases can use square roots, and only certain cases can use factoring. Not everything factors. Okay. Not everything factors. Okay. So if just using square roots from the get-go or factoring doesn't work, we do have our method of completing the square. So we can complete the square first, and then we can use square roots. Okay, so that's where we look at that completing the square process. I'm not going to do these two examples because we did plenty of them before. But yeah, we could complete the square. But we don't always have to complete the square. We are going to come up with a shortcut. The quadratic formula is a shortcut for completing the square. And where it comes from, it comes from taking a general quadratic, ax squared plus bx plus c equals 0. So in this case, a, b, and c are any real number. If a, b, and c are any real number, then basically this represents all of the possible quadratics in the world. And so we are going to complete the square on this to come up with our shortcut quadratic formula. So how this works is we're just going to go through our complete the square process. Okay, so first our complete the square process is we get rid of this constant guy and put it over here to the other side. So I'm going to subtract c from both sides equals then negative c. Step 2, we also cannot complete the square if there's anything multiplied by x to the second. We have an a there, so I'm going to have to divide both sides by a. So this first term divided by a is just x to the second plus b over a, x, equals negative c over a. Okay. So far so good. We just subtracted c divided by a. Next step is we can actually complete the square because I have x squared and b over a x. So the complete the square process is we look at our linear coefficient and we cut it in half. If I want to take b over a and cut it in half, it's going to be b over 2a. And then I square it, and that's what goes here. And then I also need to add it on to the other side as well. So I need to figure out what b over 2a squared is. So I'm going to multiply b over 2a times itself. B times b, b to the second, 2 times a times 2 times a, 4a to the second. So I am going to add a b to the second over 4a to the second to both sides. Okay. Now, on this left side, I need to get a common denominator. So I'm going to multiply the numerator and denominator by 4a. So that gives me a denominator of 4a to the second and a numerator of b to the second, and this becomes 4 times a times c negative. So we're going to have b to the second minus 4 times a times c. We do it alphabetical. Okay, that's on my right side. My left side is going to factor into x plus b over 2a squared. Okay, so b squared minus 4ac. This might look like gibberish to us right now. So at this point, we square root both sides, right? Oh, ooh, missed that. So we square root both sides. So we would have x plus b over 2a equals plus or minus. If I square root both the numerator and denominator, the square root of 4a squared would be the square root of 4, the square root of a to the second. But the square root of 4 is 2. The square root of a to the second is a, so my denominator becomes 2a. So now to get x by itself, we're going to subtract that b over 2a from both sides. So x is equal to, now if you notice, these have common denominators. And I'm just going to put this negative b, I'm just going to flip-flop these. So I'm going to do the negative b first. We're going to put it all over the common denominator of 2a. Okay, now if you notice, this tells me that x is equal to the negative of b plus or minus the square root of b squared minus 4ac all over 2a. Again, remember where the a and b and c came from. The a, the b, and the c come from up here. The a is whatever's multiplied by the x to the second, the b is multiplied by x, and the c is the constant. So if I can get my quadratic to look like this, which this we refer to, this is what we call standard form. And if I can remember this thing down here, I can just plug in the A's, the B's, and the C's, and then just do the math, simplify that down to be able to then get to my solutions. It gives me what x is equal to. And isn't that my end goal? Figure out what x is equal to. Okay. Now you might be like, oh, Miss Neal, how am I ever going to remember this? Well, we put it to a song. So there's a bunch of different songs for this. I'm just going to introduce you to one of them. It goes to the tune of Pop Goes the Weasel. So here it goes.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay. So that is, you might, okay, so I think it just helps. Let's go ahead and let's show you how to use this. Let's use this quadratic formula. I'll walk you through the process. And so basically what it's doing is it's completing the square for us, so we don't have to do it. Okay, so here I'm asked to solve x squared plus 10 equals 2x using the quadratic formula. First, standard form. Get it to standard form. Get it to standard form, which involves, on this case, just rearranging a few things. I'm going to subtract the 2x from both sides. So x squared minus 2x plus 10 equals 0. Now, identify my a, my b, and my c. My a is whatever's multiplied in front of my x squared, which in this case it's 1. So there's a is 1. My b is, be careful, it's negative 2. And my c is 10. So I'm going to write the quadratic formula down. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. Always write it down first before you use it. Promise you it helps you remember it. Now I replace. So negative b. So b is already negative 2. So I need the opposite of negative 2, which is 2, plus or minus the square root b squared. Negative 2 times negative 2 is 4. Minus 4 times a is 1 times c is 10. All over 2 times 1. So 2 plus or minus the square root of 4 minus 4 times 1 times 10 minus 40 all over 2. 4 minus 40 is negative 36, so x equals 2. The square root of negative 36 all over 2. 2 plus or minus the square root of negative 36 is 6i all over 2. And now both of these are divided by 2, so this is 2 divided by 2. 6i divided by 2. 2 divided by 2 is 1, plus or minus 3i. Ta-da! Okay, some pitfalls. Okay, first of all, be really careful with the b squareds. If it's negative times negative, which makes that positive. That b squared is always going to be positive. Be careful with this negative. Subtract 4. So often I'll put this whole entire bit in my calculator, making sure to put parentheses around the b. Okay, so be careful with that. Second, make sure you're dividing the whole entire thing by 2. This division line goes over everything. We're dividing everything by 2a. So that means that both terms have to be divided by 2a. So now this is my solution, which I would have gotten if I had completed the square on this. If I had taken this and completed the square, I would have got this exact same result. I just didn't have to. Now, completing the square might have been faster in this case, maybe not. It's kind of a bit of a horse apiece on this one, depending on how easy it is to complete the square. Okay. So there is our solving using the quadratic formula. Okay. The last bit we're going to talk about is something called the discriminant. Okay, so in this problem that we did here, my square root ended up having a negative 36 in it. From that moment on, from this step, I knew that my solutions were going to be imaginary. All because what was inside my square root was negative. Okay, so often we're not so concerned with what the answers are, but are they real? What type of answer they are? And that's where the discriminant comes in. The discriminant is that b squared minus 4ac. It is that thing inside of that square root. So the discriminant is this guy right here. Because if that inside of there is positive, then I know I'm going to have real solutions. If it's negative, like in this case, negative 36, I know they're going to be imaginary. And if it's 0, then this plus or minus becomes moot, and I know I'm only going to have one solution, one real solution. So you can use a discriminant to determine how many and what kind of solutions a quadratic has. If it's positive, so if that b squared minus 4ac is greater than 0, then you're going to have two real solutions. Okay. If it's negative, if b squared minus 4ac is less than 0, then you're going to have two imaginary, or let's just say not real. We'll stick with the book. That's how the book does it. Two not real solutions. And if it happens to be exactly 0, b squared minus 4ac equals 0, then it's just going to have one real solution, because we won't have a plus or minus 0 is the same thing. Okay. All right, so here's our last task. So here we have a t-shirt manufacturing company's profits. The amount of money they make can be modeled with this function, where X is the number of t-shirts sold. Can the company's profits ever reach 90,000? So we're not actually asking when does it reach 90,000, can it reach 90,000? So I want to know, when do the profits, can they equal 90,000? Well, we know the equation for the profits is negative 0.05 x squared plus 125x minus 3,600. Can that equal 90,000? So first, get it into standard form, get it equal to 0. So we're going to subtract 90,000 from both sides. So that negative 0.05 x squared plus 125x minus, that would be 93,600 equals 0. So can the company's profits ever reach? So in other words, is there a solution to this? Is there a real solution to this? So I'm going to just look at the discriminant. We don't actually need to find the solution. We just need to say, is there one? So it says you can use the discriminant to analyze the company's profits by finding whether there are any real solutions. So I'm just going to do b squared minus 4ac. So my a is, again, just that negative 0.05. Oh, I keep doing that. There's my A. My B is 125, and my C is negative 93,600. Okay, so we've got B squared, so 125 squared, minus 4 times A, which is negative 0.05, times C, which is negative 93,600. Okay, so now at this point, we would grab our calculator out. Calculator. And let's go ahead and let's go side by side so I can actually see the problem. Oh. Sorry, there we go. Okay, so we need to take 125 squared minus 4 times negative 0.05 times negative 93,600. And I got a negative for this. Okay, so this guy, I don't know why it's not letting me write on it. Sorry guys, just a minute. So this ended up giving me, let's do full screen. I don't know what's going on. Let me out. Oh, I didn't know I could do that. There we go. Okay, so this, sorry, ended up giving me a negative. Since I ended up getting a negative, that tells me that there is no real solution. So no, my profits can never reach 90,000. No real solution. So can the companies? No. So no, it cannot ever reach 90,000. All right.